So, good evening, friends. Our new topic with cameraman Rima Jaiswal is perfect classical mechanics is quantum. Okay, friend, suppose I have a rigid wall, very rigid wall, and I have a spring of some material connected with it. For a brief moment, we are ignoring the effect of gravity. We are ignoring it. Okay? This is a spring attached to a very rigid wall. Now suppose this is by applying force on this spring continuously, spring is changed. Here only. Next position, spring is deformed so that it is compressed. Okay, cameraman? So its length decreases. This same spring changes into this length. Okay, by application of constant force. Okay. So you can see that this spring is relaxed initially. Okay, but this spring is compressed. What is compressed? Okay, so here this spring has relaxed, so we assume potential energy is 0 because interatomic distances are high. Okay, but with application of force we have done some work, so that now all the work done by us is converted into its decreased interatomic distances, and now this compressed spring has potential energy. Okay, equal to work done, F into change in F dx, what you can say, integral, something like that. This is spring. Okay, but now ignore all these effects. If role of force, you but see just only spring only. Okay, you don't see all these force. Spring was naturally here, now it is in compressed state. Okay, clearly this spring has extra energy compared to this relaxed spring. That is, compressed spring has more energy. Compressed spring has more energy compared to its relaxed counterpart. Energy of relaxed spring. Okay, cameraman. But here also it is not moving, here also it is not moving. Okay, so this extra potential energy in this compressed spring change the nature of spring. Interatomic distances are more here, but here interatomic distances are very less. So this extra energy is reflected in increased mass. Okay, why increased mass? Interatomic distances are more in the same spring, but interatomic distances are very less in the compressed counterpart. Okay, this system as a spring has more energy because it has more potential energy. Okay, and by Einstein equation, energy and mass equivalence, we find that compressed spring mass is more than spring in relaxed spring. Okay, because compressed spring has more potential energy. That means increase in potential energy, okay, increases rest mass. Increases because both are at rest. Increases rest mass. Okay, cameraman. So, if this is the situation, now we consider a very long spring. Very long spring. Oh? Very long spring. Okay. Now, at some point in this very long spring, at the end, for example, we have some type of compressed spring. Some type of compressed spring. Okay. This compressed spring in this very long spring is our electron. Is our electron. Okay, cameraman?
Yeah.
With the passage of time, you will see that this electron at some compressed part, it has extra mass compared to this long spring, very long spring. Nah. So this is mass of electron, and compared to this mass, it has extra mass. Nah. So we neglect this relaxed mass. We neglect this relaxed mass. Okay.
Yes.
So this spring is massless now. This spring is massless. But electron has mass, compressed part. Okay.
Yes.
And of course it has some velocity, for example. So that it is moving in this direction. It is moving in this direction. Okay. So that is, it has mass as it is compressed spring, and also it has velocity also. So it has electron has some momenta. Okay. With the passage of time, you will see that this portion of springs, mass and momenta, will ultimately be converted into, at the end, all these very long spring, for a very long time, spring connected to wall, its nature will not change. Its nature will not change. Okay. So its nature will not change. So wall will assert no force on this part of spring. Okay. Wall will assert no force because nature of spring is same. But closer to it, nature of spring will change. Okay. Ultimately, here also nature will change. Nature of spring will change. Okay. And whole system finally will look like a compressed spring. Uniformly compressed, more or less uniformly compressed spring. Of course, nature close to wall has also changed at the very last moment. Very last moment. Okay. That means, cameraman, we are seeing that what is the situation is that for a very short period of for most part of the time, okay, here for example, spring has no mass. Okay. But at the end we have some electron as a compressed spring. But now it has, suppose it has mass and velocity. But here we don't have any mass. Very long springs of some mass. But when we applied force for some distance, that is, we have given some total momenta. That momenta converted into mass. Similarly, electron momenta is converted ultimately into increased mass. Increased mass, of course, velocity is very less. Velocity is very less. And here, electron mass is less, velocity is more. Okay. So actually, what we are seeing is that for most part, during the journey of electron as a spring, for most part, wall close to the spring is very similar. No? So that wall exert no force on this system overall. So what we are seeing a transformation where mass of the system, electron plus spring, increases and velocity decreases. So that at the end we reach this stage. Velocity very less, mass increases. But overall momenta is constant. But at this point, nature of spring is changed close to wall. So that wall now exert a force for a very brief time. And suddenly when velocity is very low, approximately close to zero, but mass is very high, of course momenta is fixed, wall exert very small amount of force, so that mass is very high but velocity is very less, but is in opposite direction. It is in opposite direction. That is momenta's magnitude here, when whole system is moving in this direction, most of the time is constant, and when whole system moves in opposite direction, for a brief moment force is exerted, so then momenta is reversed. But the magnitude is always this mod p. Okay. Now with starting point, mass is very high, velocity is very less, but it is converted into what? Mass is very less, velocity is very high. Okay. This is classical physics at perfection. So for any oscillatory system, something, what we are seeing that electron is something like a at every, when electron is moving, it is oscillating, for example in one dimension, then at every point in a cyclic way, density is changing in a cyclic way. Okay. That is, electron is something like a standing wave, where at every point density is changing like psi xt. Okay. In density is changing like psi xt. Since every point a density is changing like psi xt, so this is wave formulation. Okay. Now in this standing wave, momenta is fixed. Okay. And magnitude of momenta is fixed. Okay. And since force is applied for a very brief moment, magnitude of momenta is fixed. And most of the part spring close to the wall, whether here or here, is natural. That is force applied is for a very minimal period. Okay. But overall we see most part of the journey, magnitude of momenta is fixed and system is reversible. That means for most of the part, total energy E of the system is constant. Okay. Total momenta is also constant. Constant of the spring. Magnitude of momenta is also constant. Of course, but mass is changing. Changing. So overall energy equation in classical sense is, for spring, potential energy changes. But momenta of the spring is fixed. Momenta of the spring is peace, but total mass of the spring changes. Mass of the spring changes. Okay. So this is constant. This is constant. This is constant. Okay, cameraman. This is constant. This is constant. So what we are saying, when mass increases, potential energy increases. Okay. And when mass increases, kinetic energy decreases. And when potential energy increases, rest mass increases. Okay. In terms of Dirac formulation, in terms of high moving, very fast moving spring in this fashion, in terms of Dirac formulation, energy can be given as beta mc square plus sigma alpha x px into c. Okay. Since px is constant, px is constant and energy is constant. Okay. But it is what changing? Rest mass is changing. Rest mass is changing. It is changing. Okay. So rest mass is changing, so that velocity portion is changing. Velocity portion, that is alpha x, is changing. Okay. That is, here beta is a function of position x. Beta is a function of position. Okay. Similarly, alpha x is also function of position. At least position. Okay, cameraman. So in Dirac formulation, alpha and beta are matrices of 4 by 4 order, but in our formulation in this model, beta is a matrix of infinity cross infinity, alpha is a matrix equivalent to infinity cross infinity, and psi is a matrix of spinors infinity cross 1. Okay. Okay, cameraman. That means when you sum all these equations, when you sum all these equations multiplied by psi, and when you sum all these equations, when you sum all these equations, so what you will get, E into psi is equal to beta mc square psi plus sigma alpha x px c multiplied by psi, where beta is function of x, and alpha is also function of x. Okay, cameraman, position. And what is psi? Psi is nothing but sum of infinite spinors. Sum of infinite spinors in our formulation. That is what is psi? Psi is summation of sigma 1, sigma I, where I is 1 to infinity. Okay? 1 to, cameraman, see here, 1 to infinity. So in case of spin, in case of cameraman, in case of spring, spring at a general point during this movement of spring, density of spring will be different at different points. Density of spring will be different at different point. But that means interatomic distances is a function of x. But atom structure is same. Atom structure is same. But in case of electron, cameraman, there are no atoms. Okay. But electron can be represented at a variation of density. density. In a very relaxed state, when the spring is very relaxed and very long, electron can be represented by a massless distribution of massless particles. Okay, cameraman. And these massless particles, movement of these massless particles are interaction between this, that is density changes in the density changes in this massless particles, density of this massless particle, negative massless particles, creates the property of mass, because at some density interaction between massless particles takes place and massless particle coalesce to form mass. Somewhere major mass, other where coalescence are less, density are less, there are minor mass. Okay, surrounded by minor mass. Okay, cameraman. So that is massless particles. Change of density of massless particle at this major mass can take place according to three terms: diffusion of massless particles, psi xt, particle and small amount of mass colliding, that is rebounding these massless particles. Second term, b times velocity can be represented by cloud, particle plus cloud by something like psi x. Okay, and net particles, due to both of these terms, some particle will be consumed in the formation of mass, because particles will change nature. So s times effective collisions we have to take, so that velocity in this term can be written as, like previous example, Deva by Deva x psi xt. Okay, cameraman. These three terms. Okay, these two terms are Schrodinger terms, and this single derivative term is combined with this term. This term is a Dirac term. Okay, cameraman. But when electron has no mass, it is composed of only massless particles, no cloud, for example, then also these massless particles have energy. So in Dirac formulation, beta mc square plus sigma alpha x pxc, when there is no mass, energy will be zero. But mass is created de novo from these massless particles. Okay, and this rest mass is changing. But when there is no mass, there is some energy. There is also energy of massless particle. So that energy of space has to be added in this equation on both sides. Energy of space. Okay, on both sides, energy of space. So that total energy is now, it is correct equation, beta mc square plus sigma alpha x pxc, and this is what? Energy of space. Okay, now multiply both sides by psi. Okay, you will get E into psi I h cut Deva by Deva t of psi, and this beta mc square psi. Okay, and this you will get minus I h cut c sigma alpha x Deva by Deva x of psi. Two terms. Third term is space energy into psi, which is distributed in massless particles according to equation, how it is accumulating, and it will be accumulating by the term something minus times space constant h cut square by 2m Deva square by Deva x square of psi. Okay, this is Schrodinger term. Okay, that is in electron system, mass has been created by these massless particles, interaction of massless particles. Okay, and interaction takes place because change in density of massless particle. change in density of massless particle. Density of massless particle is given by psi xt. Okay, that is mass and massless particles are fundamental. Higgs. These are Higgs massless particles, huh? But this massless particle can be derived classically. For example, in the Rutherford orbit, electron as a single particle, it is moving at a distance r. Then it is a mvr is constant. Okay, is constant. Since r is constant, mv is constant. That is momenta is constant. Since r is constant. Okay, magnitude of momenta is constant. It is constant. Okay, but suppose electron is not a single particle, but it is cloud, and it is single particle. It is radiating radiation. Okay, Maxwell. But it is accumulated in cloud. So that center of mass of electron as a particle plus cloud is always at a distance r. Okay, but particle portion, which was big initially, loses radiation, so it loses momenta. Particles radii decreases to minimum. Okay.
Yeah.
Oh, okay. Okay. So here mv square by r is given by Coulomb force divided by r square, na? But here it can be written as mv multiplied by v upon r. Okay.
अभी आवाज आ नहीं रहा है.
आ रहा है.
अब आ गया.
Okay, cameraman. तो mv v by r equal to what, cameraman? K times E upon r square. Okay, cameraman. What I am saying is that what is mv? It is p. That is pv. That is pv by r square is equal to k times charge on nucleus multiplied by charge on electron upon r square. Okay, cameraman. But what is p here? P is mv. But what is mv? It is momenta. Momenta of what? Electron as a particle plus cloud. Whether it is single particle or small, or whether it is single particle, big particle, okay, or smaller particle with bigger cloud. It is closed system. Okay, radii is fixed. So P is fixed. Okay, cameraman. So P is what? Momenta of electron as a particle plus cloud. It is fixed. So it is P is fixed. Okay, P is fixed. But particle plus cloud velocity is changing. Particle plus cloud velocity is changing. Here particle and associated cloud has very less velocity. velocity decreasing. Okay, cameraman? But R, the center of mass, particle plus cloud center of mass RC is fixed. Okay, cameraman? Is fixed. So what we are saying? Decrease in centrifugal force. Decrease in centrifugal force. Centrifugal force is decreasing. So Coulomb force should also decrease. And Coulomb force, since all this Coulomb force, K is constant, N is constant, charge on electron, particle plus cloud is constant, how it will decrease? Coulomb force, how it will decrease? If R decreases, R increases. Here R increases. But you can see that center of mass is fixed, R is fixed. So mass center of particle plus cloud is fixed. But velocity decreasing, centrifugal force is decreasing. But here to reduce the Coulomb force, we have to increase the R. How R can be increased? If center of mass which is RC is fixed, but center of charge is different. That is, electron as a particle or cloud, center of charge changes. When electron is a single particle changes into particle plus cloud, centrifugal force decreases, but charge separations occurs. When electron is a single particle change into particle plus cloud, charge center shift, charge center increases. So distance between nucleus plus charge and center of electron is a particle plus cloud charge center, distance increases. Okay, but center of mass is fixed. So we can see that center of charge, that is RC increases, but center of mass of electron plus cloud system is fixed. This is known as mass and charge separation. Mass and charge separation. In this way, mass and charge separation can be achieved classically, and electron can be made from massless particles only. Okay, cameraman, now give me. So please see my videos. Okay, so please see my previous video, and Radha Jaiswal is watching. Hopefully many other persons are also honorable persons and with the diverse backgrounds are also watching. What I want to okay, so what I want to say is that mass and charge separation can be achieved classically, not only by quantum physics, by complex algebra, but mass and charge separation and Higgs negative massless particles can be achieved by applying classical principles, but classical principles has to be applied in a very generalized way and also in a very detailed way with perfection. For example, as our spring model is showing, and you can see that in this situation, in case of electron, mass of electron has been created de novo from the interaction of massless particles, not at one point, at various points. At various points it creates cloud, but where maximum mass, actually maximum disturbance is seen, electron as a particle is seen, and that defines the system. But when you see electron as a single particle, then of course momenta of that single particle will not be conserved. But when you see electron as a particle plus cloud, then electron as a single particle, angular momenta plus cloud as a spin, then electron as a particle plus cloud, that is angular momenta plus spin, it will be conserved. It will conserved in all the three directions, px, py, pz, and of course overall momenta will also be conserved, and that's why it is a distributed system with different density of massless particles, with different density of cyclic reversible changes in the density of electron mass at various points. So it is something like a standing wave, na? But in standing wave, when you apply momentum operators, you will obtain either px, py, pz, which are conserved in all the three directions as a magnitude, but what is px, py, pz? It is sum of angular plus spin momenta in all these directions. But when you consider electron as only a single particle and ignore this cloud, then you will see that px, py, pz will not be conserved, and it will represent only angular part only. And also you will see that electron, when you see electron as a single particle and you ignore its cloud, then you will see that electron as a single particle will have not one momenta but a range of momenta. Electron is a single particle, and when electron is very small but cloud is very big, so electron will have very less momenta. Electron as a single particle will have very high momenta, na? So range of momenta, and similarly you will see electron position not at center of mass but in a range that and when you see electron as a single particle, you will get the uncertainty principle in a very, very natural way. Jai Hind, Jai Bharat, Jai Visv, and thank you Rima. And I myself Manish Jaiswal from Arkanyachara, Muthiganj, Prayagraj, house number 869, and from India, and I love quantum physics and classical physics, and I am trying to close the gap between classical and quantum physics, so that general relativity, principles of general relativity, great Einstein, and principles of quantum mechanics or mathematics of quantum mechanics can be entangled into a unified field theory. So as a layman, outside university person, I want to give some tribute to our great legends, that is great scientists of quantum physics, including from Einstein to Bohr. And of course, beginning of quantum physics starts with Planck, and statistical analysis starts with great Boltzmann. Hopefully you have enjoyed, and this is a way a non-university person, outside university person, a layman, want to add something. I may be totally wrong, I may be very much wrong, but we can give some new perspective and somehow close the gap between quantum and classical, and instead of dichotomy we have unified field theory, then we can better understand the nature and our universe. Jai Hind, Jai Bharat, Jai Visv. It is a very small contribution from an ordinary layman, but I love my university scientists, university students, young or honorary professors from a young university graduate to a very high Nobel laureate professor across the world. Jai Hind, Jai Bharat, Jai Visv. Thank you, sir.